We have programmed this FPGA board to be able to show VGA graphics, contains a memory unit, is able to control several different I/O devices, and on this we have
like the keyboard that we are connected to it. We have made I/O device to handle that, so we have a smooth bar doing left and right. Where we on the board we have we have programmed a game where that can be played on the FPGA, and the units we have programmed onto the board via hardware describing language. So, and we have made this Breakout game a classic arcade game where you can shoot a ball up and then smash some boxes, and where we have implemented some different angles so it isn't the same, and you have some lives plus a score, and then it's just then you just need to hit them all, and some of the boxes have more life than just one. You can see what number of life it has on the color. Where blue is 4, yellow 3, green 2, and red 1. And then you can get up to I think it was 360 points. And then it's just when you have destroyed all the boxes, and then you die when the ball comes under the bar, then you can make it go up.
Yeah, again. Classic Breakout game. Really.
Classic Breakout.
We have implemented a few extra functions. When you hit 100 points, 200 points, 300 points, you get an extra life. And we also played with the idea of implementing more things, but we ended up prioritizing a smooth gameplay with especially these angles.
We could have implemented some power-ups, but we didn't have the time. But we have some more control over the ball, so you can fire the ball here, and then you can shift angle by hitting on the side the ball comes from. Then it goes right back with the same with maybe a different angle depending on the angle it comes in on. You see there. And if you then hit the other side, you get a sharper angle. And then we have also implemented that the ball goes faster for each time it hits a box or the bar, and we of course have a limit on that speed, so it doesn't get too difficult.
Can you talk a bit more about the implementation? So is it, you say that you've done it on an FPGA, which is programmable digital electronics hardware.
Yeah.
Question is there any processor involved in this, or is it just hardware, pure hardware, nothing else?
No, we have programmed the game on in C, where all the logic of the game is. We decide where the ball is, and then we send the data to the FPGA that then draws it on the screen.
Okay, so the C program, is it running on a PC?
No, it's running on the FPGA.
Okay, so how is it running on the FPGA? Do you have a computer on the FPGA?
Yeah, we have we have programmed it to we have how to say?
We have different kinds of components
that
all together.
Yeah, we have some different components on the FPGA that combined can do that. We can send the C program to the FPGA and then run it on it.
So you talk about different components. Can you give me examples?
Foremost, we have the CPU, obviously, and we have memory components, both to store the C code in, so it's able to be executed, but also various things we need to keep track of. That could be the score, the lives, position of the ball, these things, and I/O devices, as we mentioned before, is also components that are integrated.
UART.
The UART, which is able to both send and receive information to the PC, so we can code it on the PC and then send it to FPGA using this component.
So you use the PC just to program the small computer. It's not part of the gameplay.
Not at all. Not at all. It's not even connected right now. So
it is connected, but
it's just running on the FPGA.
And you've built your own computer on the FPGA yourselves.
Yes, exactly. Yes.
Out of parts. Okay. If you look back, what is the thing that you are most proud of in this project?
From my side, it's probably the bar, but because it has had a lot of problems with angles and so on, and get the ball to get a good angle, but at the same time be able to smash the balls or boxes correct.
For me, it would probably be the moment when we had a functioning computer on the FPGA, which was quite a huge thing, really. And we could write memory to it, write some data to it, and we could read it again, and it would show the correct memory, and it just works. And we could make a little light up when we hit a certain key on the keyboard. Those were great things.
You can see here, enter space.
Oh yeah, left over from when we when we were debugging.
Yeah.
Okay. Thank you.